Okay, so for the 2-1 section, there isn't graphing involved, so feel free, again, put it on graph paper or non-graph paper, doesn't matter to me. We're going to do some of the odds together. Well, I'm going to jump around a little bit. So just number the ones we do together. Write 2-1 above it so I know that it's 2-1. Problems 1 through 6 say, to state the domain and range, graph the relation and tell whether or not is a function. For each function, state whether it is discrete or continuous. Okay? So we're going to use Desmos to complete some of this because we haven't got to spend a lot, we haven't jumped into the deep dive of graphing yet. So I don't expect you to be able to graph them, but you need to draw me just a little sketch, okay? So number 1, what you're looking for the domain are the set of x's. So you're just going to pull those x values 1, 2, 3, and 4 out. And just list them in like a little set bracket notation, okay? Now, for range, we are going to pull out just our y values. If anything repeats, don't write them more than just once. But all of the y values are 2, 3, 4, and 5. Now it asks to determine whether it is a function or not. Yes, this is a function. And because there are 4 exact and only 4 exact points, it is called discrete. Okay? So that's what you're doing for 1 and 2. I want to talk about what you should be doing for 3, 4, 5, and 6. Okay? So let's talk about the ones that are an equation. Now, if the ones that are an equation happen to be a function, they would be considered continuous if they are a function. So let's take a look at number 3. So what I want you to do is I want you to open up a tab in Desmos. Okay, open up a tab in Desmos, desmos.com, graphing calculator. So find a tab in Desmos. And I want you to type in y equals x squared. Whatever the equation happens to be, please type it in, okay? And once you type it in, kind of note some of the, important points. But just for this, I really just need a general shape. And then go back to your sheet of paper. And then for number 3, this is what I expect to see. Just a little x and y axis with a parabola that looks like that. It does not have to be super accurate for this. That is not the intent. And then because a vertical line is only hitting it in one place, is it a function?
No. Yes.
If a vertical line can only hit it ever in one spot and only one spot, it's yes, it's a function. And this kind of function, when you had to type in the equation, and there's a million, trillion, bazillion points that we could choose from, it's called continuous. Okay? Now, I want to type in, we're jumping to number 6. Can you jump to number 6? Everybody see what you're doing for 3 through 6? Go to Desmos, type in the equation, draw me a little rough sketch, say yes or no. Okay? So for number 3, and then if you're having trouble using Desmos, all you got to do is ask, okay? So number 3, the answer was yes. I drew a little picture to prove it. The vertical lines only ever touch it once, so it's a continuous function, okay? Now, I want to jump to 6, so I can tell you what you look for what is not a function. So everybody go to your Desmos tab. And this time, we're going to type in y equals, and if you hit functions, I believe there's absolute value, but on your keyboard, I just don't, let's see, I need absolute value. Oh, there it is. There is a little button for absolute value of y. No, x equals the absolute value of y. There it is. X equals the absolute value of y. Once you get the picture in, all you're doing now is graphing a very rough sketch. So you notice it's just like a V turned on its side, okay? And it does touch the origin at 0, 0. I don't need anything more than that, okay? So for number 6, all you're doing is making a little XY axis and making a little V on its side. It doesn't have to be anything more fabulous than that. How many times do vertical lines hit this one? Especially vertical lines over there on the right. How many times is our vertical line being hit? I'm sorry, how many times is the vertical line hitting the graph now? 2. So that says it's not a function. So that's why knowing what the graph looks like is so important. So 5 through 6, draw a very rough little sketch. I don't need to see any kind of graph of 1 and 2. That one just lists the what it is. Now I do want to talk about domain and range, okay? 3 and 6, we're going to do domain and range for that. 3 is a type of function that I can input any x I choose. You know, if you think about, I can pick 1, I can pick -1, I can pick 2, I can pick 7, I can pick -7, I can pick a half, I can pick -1/2. So when that's the case, the domain is all real numbers. So when your input has no restrictions, what kind of things have a restriction? Square root has a restriction. We can't plug in negatives. A fraction has a restriction. We can't put zeros in our denominator. But this one, there's no restriction. Yeah, I could put in whatever I want. How can you tell from the graph? The graph is going to help us for this. See how this graph eventually will keep going to the left and keep going to the right without any kind of break or interruption? That also tells you that. It's how your graph stretches from left to right should match the domain, okay? Range is the set of y values that popped out. So it really depends upon the function. Some have y values that can go all the way to the bottom of the graph, -infinity, to the top, positive infinity. What is the lowest point of this particular graph? 0. That's our lowest point. What's our highest point? Yeah, I can go as high as it wants. So the range would be all y's that are greater than or equal to 0. Now that's one way to put it. When you get to Algebra 3 or pre-calc, you can use interval notation for my class if you just describe it. You can even write the words, all y values that are greater than or equal to 0. Okay? So that is that first section, 1 through 6. Use Desmos to assist you in the graphing process. Let's take a look at 7 through 10. All you have to write on your paper is yes or no. Okay? It says, if we include the points shown into the function that already has these points in it, will it still be a function? Now, what values are the most important when we determine if something is a function? The x value or the y value? Which is the most important value to look at? The x value. What are we looking for that would mess up it being a function? 2 of the same numbers. So all we're going to do is compare what we have added, 1, 3, was 1 already used in the original set as an x? Was 1 already used? Yes. So that's a no. Can't be a function because the 1 was already used. Let's do 8. In number 8, the point is -1, 3. Has -1 already been used on our list of x's? No. So that one's a yes. So for 7 through 10, all I need to say, yes, no, nothing else. Okay. And now I would like to look at 11 through 17. Now, 11 through 17, we are taking and inputting values into the function. We're going to do one of the 11 through 13. See that notation there? See how it has an F in it? So for 11, 12, and 13, we're using the F function. For 15, 16, and 17, we're using the G function. So let's do one of each, okay? We're just putting in a number, inputting, see what we get out. So let's plug in, the half in. Let's do 13. Okay, so all I do when I am inputting into a function is 1/2, take out the x, replace it with our input, 1/2, and then do order of operations. Now the best way to add 1/2 and 7 is, if you think of 7 as 7 over 1, I need to get a common denominator of 2. So just multiply top and bottom by 2. That's a nice little trick. It works really well, and it's easy to change that. And so we really get 1/2 plus 14/2 is 15/2, right? Okay. So once you get a common denominator for fractions, it's great, because all you have to do is add up the tops, keep the bottom, okay? Now to multiply fractions, I'm just reminding you of these rules because it's very easy to forget when we don't do that often. You just multiply tops with tops and bottoms with bottoms. Nothing more fancy than that. So let me say that again. To multiply fractions, multiply tops with tops, bottoms with bottoms. You can reduce if a top factor is the same that you can reduce in the bottom, but there isn't in this case. 1 times 15 is 15. 2 times 2 is 4. Okay? And now let's do 14 together. I didn't even see 14 was there. Let's do 14 together. Okay, so our input has some letters in there, and that's okay. Take out the x, replace it in the x spot in this function here to the left there, that f function. Okay? Okay, when we do that, first let's just do that. We get 1/2. A plus 2 replaced the x plus 7. Now this is one where there's not much we can do. What is 2 plus 7? What is 2 plus 7? 9. So all you got to do is do half of a plus 9. You don't have to distribute. If you want to distribute the half in, go for it. You don't have to. Because I don't know what a is, if a is 1, I do one thing. If a is 7, I do something else. So when it's just some other variable, just leave it. Go as far as you can and go, that's it. I plugged it in. That's what I got. Don't overthink it. Everybody good using our f function? So you got 2 more of those to go. Everybody good with the f function? Okay, now we're going to use the g function. We are going to plug in, I want to do 17 and 18 for that one. Okay, for g. So what are we doing? We are taking out the x. We have 2 x's to replace with our input value, okay? So we're going to get 1/2 plus 1 squared minus 2 over 1/2, okay? Now I want to show you that 2 over 1/2, so I don't have a lot of room there, so I'm going to go to a blank sheet of paper, okay? So I can show you the trick. This works every time, okay? Make sure that both numbers show a top and a bottom, a numerator and a denominator. How could we rewrite 2 so we have both a numerator and a denominator? How could we rewrite 2 so it has a numerator and a denominator? Yeah, just put it over 1. So any kind of integer or whole number, just put it over 1. So that's 2 over 1 and 1 over 2. Okay. Now if you see that, to divide by a fraction is the same as multiplying by its reciprocal. So if you want to rewrite that as 2 over 1 times 2 over 1, that will work. But I'm going to show you a trick that works really nicely, especially as we go into more complicated fractions later in the year. I call it big C over little c. Big C over little c. It works every time. If you multiply the outer 2, that's big C. And then you put it over the multiplication of the little 2, the inner 2. That's little c. So it really becomes 2 times 2 over 1 times 1, or 4 over 1, or 4. Okay? Big C over little c is a trick for what's called a compound fraction, or sometimes a complex fraction. It's just when you've got more than one piece, that's just a really good way to big C over little c. It works. Connect the outer 2 for your big C. Connect the inner 2 for your little c. Okay. So that's 4. 1/2 plus 1 is 1/2 plus 2/2. Remember that trick we did with the 7? We made it 14 over 2. You can make that 3/2. And then we knew that was 4. We got a 4 there. Anybody know how to square a fraction? Anybody know the rules of how we could square that 3/2? What do you think?
Multiply by itself.
Yeah, you can rewrite it twice. It ends up being the multiplication of itself. So it ends up being the top squared over the bottom squared. So if you just think of it as, hey, I'm squaring the fraction, square the top, square the bottom, you got it. So that's 9/4 minus 4. Now, 4, we can do the trick again. Common denominator, put it over 1, multiply by 4. 9/4 minus 16/4 is negative 7/4. Negative 7/4 is your answer for 17. Okay, so make sure you have that down, and then we're going to do b minus 1, which is probably one of the hardest ones on this page. We'll do 18 together. Okay, let's talk about everybody good with 17 and how we did that. I don't care about improper fractions. If you want to go to a mixed number, good for it, but it's not super helpful, so, okay. Let's take a look at b minus 1. Now, I'm going to write the equation over top of it. And just tell me that I did it right. Okay, that's the equation, right? Or the function. Okay. So remember what you're going to do. You are going to remove the x, and it's going to be replaced with b minus 1. So that's the first thing. Just take out the original x, plop in b minus 1. Okay? So it's going to be b minus 1 plus 1 squared over negative 2 over b minus 1. Does that make sense how I got that? Okay. Now, what's great that they've done for us is negative 1 and positive 1 cancels out. So that's just b squared. I'm going to put this b minus 1 in parentheses to just kind of really, so that kind of pops out at you a little bit. B squared is b squared. I have no idea what that is. B minus 1 is b minus 1. I have no clue what that is. So don't think I can do anything else. I mean, even getting a common denominator for there is pretty impossible because I don't know what b is. If b was 7, the common denominator would be one thing. If b is 10, it's something else. So just leave it. That's fine. That's our final answer. Okay? I inputted b minus 1 for the x's. I simplified as far as I could go, and that's as far as I could go. So just stop. Okay? That's a very difficult one. So if you followed that, that's good because that means it's starting to click there a little bit. So everybody good with the 2-1 section? We did about half of that, okay? And I believe it's marked that, check the due date, but it's not due today because I didn't know how long it's going to take. Let's check. Yeah, it's due tomorrow at midnight, so. Okay, so that is 2-1. Now let's talk about 2-2. Now 2-2 is about those linear functions. In this bottom section, we are going to have to graph it, but that's the only ones that I expect to see on graph paper. The other ones you can use graph paper if you want, but it doesn't bother me. Let's take a look at this top section, please. Okay, it says for 1 through 6, you're just writing yes or no. That's it. Is it a linear function? So if we take a look at some of the ones I see a problem with, okay? There are 3 there that the answer is yes, it's a linear function. There are 3 that there's a no, okay? Now let me give you the rules because I don't want to give you the answers just yet. I want you to think about it a little bit. If an x and y are multiplied together, nope. If the x or the y have a power on it, nope. If the x is in a denominator, nope. Okay, so those are the no's. If it's just something x plus something y equals a number, that's a yep. Okay, so 22, or 2-2, 1 through 6, half of them are yeses and half of them are no's. Okay, so I would like to now do problem 7, 8, or 9. Okay, for 7, 8, or 9, you are looking for your equation to be in standard form, which is ax, my goodness, which is not that, which is ax plus by equals c. So that's your standard form you're looking for. A, b, and c should be integers. A should be a positive number, okay? There should be no greatest common factor. So what does that mean? 7, you need the y over to the left and the 7 over to the right, and then you got it, okay? 8, you just got to multiply by 2 so that we have that fraction 1/2 will go away. 9, we're going to do that one together. We've talked about fractional equations before, and I said, hey, just multiply through by the common denominator, then you won't have a fraction anymore. What's our only denominator we see in number 9? What's our only denominator? 3. So let's multiply everything through by 3. Okay? So we get 3y equals 6 divided by 3, which is 2x plus 24. Now, if you do that, we want the x and y to be on one side with the x being positive and the number on the other side. So what's technically going to happen is let's take the y and put it over there. Let's take the 24 and put it over there. So then our x is going to be a positive. Okay? We get negative 24 equals 2x minus 3y. Now, I'm okay if you stop there. Technically, you should write, just flip-flop that and get 2x minus 3y equals negative 24. Okay? And the a, it says identify a, b, and c. So our a is 2. Our b is negative 3. Our c is negative 24. So that was the hardest one of those. So if you follow that, that's what you have to do for the other two. Okay? And then let's do 10. Let's do 10 together. And then you'll have the rest of the class period. Let's look at 10. It says find the x and y intercept for the linear equation. Okay? So anytime they do that, I like to make that 0, 0 chart. Because if x is 0, we find the y-intercept. If y is 0, we find the x-intercept. That's the easiest way to do that. So let's do this top one here. Let's let x equal to 0. So that will be 0 plus 0.02y equals 4. So you see how by plugging in 0, this goes away. See how that's gone? So you get that, okay? How could we solve this for y? 0.02y equals 4. How could we solve that for y? If we have 0.02y equals 4, how could we solve that? Yeah, just take off that 0.02 by division. And I think it's going to be a pretty big number. 100 maybe? Let's see. Or 200 maybe? 4 divided by 0.02 is 200. And then you do it again. Let's do it again. And let's do our x-intercept is when we let y equal 0. So that would mean this would be 0. So we get 0.05x equals 4. And then you just got to solve that one. This time, what do we divide by? What do we divide the 4 by this time? 0.05. And I think that is going to be maybe 80. Okay. That's going to be 80. Okay? You don't have to do anything with those as far as, I don't want you to do anything else. Just find the x and y intercept. Okay. Now let's talk about the graphing, 13 to 21. You can graph them by making an x, y table. Plugging in 1, 0, and -1 is an option. That is one choice. That's not a bad choice. That's a perfectly acceptable choice. Go for it. Another choice you can do to graph those is make a 0, 0 chart. We know these are all lines, so once you do that, you can you can connect the 2 points, whatever they happen to be. Another choice is to find your y-intercept and your slope, if you remember how to do that. I think we did that in 2-2b. If not, that's coming next week. But if you remember how to do that from Algebra 1. You have lots of ways to do these. Your graphs should be accurate and straight. So I want them on a piece of graph paper. If you want to use a ruler, try to make your graph nice for 13 through 21. They're all lines. So that's all you're doing for that section, okay? So you have today in class. You have all the way till tomorrow at midnight. So technically, you have a day and a half to get this done, okay? And then just make sure you take pictures of it. I won't see you tomorrow, so it's your responsibility to get this done. Make sure you've turned in 2-2A and 2-2B. Are there any particular ones from those that you have questions on? Anybody have any questions about 2-2A and 2-2B homework that you would like me to do one of them with you, any of them particular? Yeah. From 2-2A or B? A or B, which one? Huh? Oh, from the page we just did? What number, 12? Oh, for the one that says x equals 7? I'm glad you asked about that one, because in the notes somewhere, I think, you should have learned that this is a vertical line. So if we think about what this looks like, at 7, it's just a line through there. So the x-intercept is given, x is 7. Does it hit the y-axis? So there's no y-intercept. Okay.
7x, 0y, and 0, 0y.
So if you wanted to do the graph, you can use an x value of 7 with any 2 points to make it. So like 7 could be, it could be 7, 0, 7, 1, 7, 2, 7, 3. Yeah. Any other questions about 2-2A, 2-2B, or this assignment? Okay. There you go. Do your thing.